Hello guys, welcome back to my lessons. Today we're going to talk about sigma notation and an infinite geometric sequence. So let's start with a sigma notation. So sigma notation is another way of representing a series. Remember, a series is when we add the terms in the sequence, a series is formed. So the series is represented in sigma notation here. So this is how it looks. We have the E, which means the sum of, and then we have the formula on the side, which is the general formula of the series. So we're going to use this general formula to find the terms in the series to help us to calculate the sum, because they'll give you the sigma notation and be like evaluate, where you have to write the sum of this series. So we have the bottom number there, which is equals to 4, which is n is equals to 4, which means that the first term you're going to take the 4 and then you substitute it on the n on the formula, and then you get the first term. And then we have the top number, which is the 7. That is the last number you're going to substitute on the n, and then you're going to find the last number. If you take the 7, you substitute it on the n on the formula, you're going to get the last number. If you take the bottom number, you substitute it on the formula, you're going to get the first term. But then how are we going to get the sequences that are in the middle of the 4 and the 7? So we're going to substitute 4 to get the first term. We substitute 5, second term, 6, third term, and then 7, which is the last term. So this is how we're going to do it. We're going to substitute 4 first, and then 5, 6, and then 7. So our terms are going to be 4, 6, 8, 10. So this is our series. The last term is 10, and then the first term is 4. So if they say evaluate, you're going to use the formula Sn is equals to n divided by 2, in brackets a plus I, which is the last term. N is the number of terms in the series, and then I is the last term. So we have how many terms? We have 4 terms because we've written them down. And then we write 4 at n, we write 4 at a, which is the first term, and then we write 10 at I, which is the last term. If you put that on a calculator, you're going to get 28. 28, it is the sum of this sigma notation. But then you have to know what type of a series is this. This is an arithmetic series, hence the difference is 2. 6 minus 4 is 2, 8 minus 6 is 2, and we also used the sum for the arithmetic sequence, the formula of the sum for arithmetic sequence. So now let's move, and this is the next question. We're given 70 at the top and then 4 at the bottom. So the 4, if we substitute it at the end, we'll get our first term. If we substitute 70, we're going to get our last term, right? So let's write them down: 4, 6, 8, 10, and then the last term we write dots before, and then we write 136. So 136 is our last term, but we don't know the terms between 10 and 136. So what do we do if we want to find the sum? How are we going to be able to find the number of terms in this series? So you're going to use the formula of the last term because you have it, and then you're going to say Sn is equals to n minus 2 divided by 2, in brackets a plus I, which is the last term. You substitute a, which is 4, we substitute the last term, which is 136. But what about the number of terms in this series? You're going to use the formula top minus bottom plus 1. Top meaning the number at the top, bottom the number at the bottom, and then plus 1. So 70 minus 4 plus 1, that is 67. So 67 is the number of terms in this series. So after we get the number of terms, you can put that on a calculator. You're going to get the sum of this series. So what type of a series is this? there's an arithmetic series because the difference is 2 to 2, hence we use the formula for the arithmetic series to get the sum. So let's move on to the next question, whereby the bottom number is 1 and then the top number is 10. If we substitute the 1 on the end, we're going to get our first term. If we substitute 100, we're going to get our last term. So let's substitute. The first term is -2, second term 0, third term 2, fourth term 4, and then our last term, if we substitute 100, we get 196. And again, we don't know our number of terms in the series. What type of a series is this? This is an arithmetic series with difference of 2. So we're going to use the formulas for arithmetic series. And then we have Sn is equals to n divided by 2 in brackets 2a plus in brackets n minus 1 close bracket d, or you can use the formula Sn is equals to n divided by 2 in brackets a plus I, because we have the last term, so you can also use this formula of the last term. But the problem is finding the n, right? How do you find the n? You take the top number minus the bottom number plus 1. 100 minus 1 plus 1 is 100, because 1 minus 1 plus 1, that is 0, and 0 plus 100, that is 100. So we're going to use the formulas. Sn is equals to n divided by 2 in brackets a plus I. For n, we substitute 100. For n, we substitute 100 again. For a, we substitute -2. For the last term, we substitute 196. And then the sum is 9,700. Let's move to what we call an infinite geometric series. So an infinite geometric series is a series which there is no last term. So this series does not end, right? It has no ending. So let's look at the sigma notation. As you can see, the top, we see the sign of infinity. And in infinite geometric series, we have a converging series, and then we have a diverging series. So let's first talk about a diverging series, right? So we're given sigma notation here. So let's substitute k1 where we see k, and then we're going to end at, I don't know, because infinity means it doesn't end. So if we substitute 1 first, we're going to get 2, the second term 6, third term 18, fourth term 15. So there's 54, I mean. So those are our terms, 2, 6, 18, and then 54. So if you notice the ratio, remember in geometric series we have a ratio. We divide the second term by the first term, we get the ratio. We divide the third term by the second term, we get the ratio. So in this case, the ratio is 3. The ratio is more than 1, right? It's more than 1, and then it means that the terms will go up from 2. Look at the second term is 6, it's more than the first term. 18 more than 6, the previous term. 54 more than 18, right? So the terms keep increasing. So when the terms of the series are all positive, and the sum will get bigger and bigger. The sum of this series, if you calculate the sum, it will get bigger and bigger. So this is called a divergent series. So if they ask you, is this a convergent or a divergent series, what you can do is to find the ratio. Once you find the ratio, you can tell whether it's a divergent series or a converging series. So now let's look at a converging series. This is the series whereby the second term is less than the first term, so the terms keeps decreasing. As you can see, 1/16 is less than 1/8, 1/8 less than 1/4, 1/2 is less than 1. So as you can see that the ratio is always going to be it's going to be more than -1, but it's also going to be less than 1. So it's going to be about 0, something, 0, something. And the sum of the series will keep converging to a certain amount. So you'll be asked in a converging series to calculate the sum of infinity, right? The formula for the sum of a convergent infinite series is the sum of infinity is equals to a divided by 1 minus r. So for this series, specifically if we calculate this, the a we have the 1, a is 1, and then over 1 minus r. The r is the ratio, so the ratio is 1 over 2. And then always write this thing on the side to say the ratio is more than 0, but it is also less than 1, right? As you can see that this ratio here is more than 0, but it is less than 1. And then for a you substitute 1, for r you substitute 1 over 2. If you put that on a calculator, you're going to get 2. So the sum of infinity is going to be 2. Thank you so much for listening. Don't forget to subscribe to my channel, and I would really appreciate it. Thank you.